Assalamualaikum warahmatullahi wabarakatuh. Today I want to explain about the topic probability distribution. What is the probability distribution? It is a listing of all the outcome of the experiment and the probability associated with each outcome. So it has four types that we learn: binomial distribution, Poisson distribution, normal distribution, and normal distribution approximation to the binomial distribution. So for the binomial distribution, this is the formula that we can use. Also we can all the subtopic has will use the main formula that we can, and this is the variance formula, or VAR X equal NPQ. Okay, so for what is the binomial? Binomial two possible outcome, one which may be success and fail. So we can assume P for the success, Q for the fail. So for the Poisson distribution, they describe the number of time some event occur during the specific interval. Intervals such as maybe time, area, or volume. So for normal distribution, most important continuous in statistic, maybe quantity in natural science such as height, mass, age, and so on. Okay, this is our question. First question, example for the binomial distribution. First, in all day, there was a probability of 0.8 of success in army attempt to make the telephone cell. So calculate the probability of having 7 success in 10 attempt. So that's we can take out the information. So P for the success we equal to 0.8. So to find the Q, we use formula P Q equal 1 minus P, so we can get 1 minus 0.8 equal 0.2 for the Q. So our N is the 10. We could attend attempt. So we use the binomial formula, that is P X equal X and C X P X Q and minus X. So we put 2 P X equal to 7 because we 7 success, equal N, and we put 10. C X we put 7, we put in this. P 0.8 time Q X equal to 7, Q 0.2 minus 10, and 10 minus X 7. So we calculate to the calculator, we get the 0.013. This is our question, answer will be success. Okay, this is the second question for our subtopic, Poisson distribution. Okay, a life insurance salesman sells on the average 3 life insurance policies per week. Use Poisson law to calculate the probability that in a given week he will sell. So for some A, some policies, 2 or more policies but less than 5 policies. So we explain, we do the A question. So we know lambda equal to means. Okay, X equal to lambda equal to NP. So we know means has given in the question. So lambda is 3. So for the sum of policies, we assume that more than 1. So we using the formula P x equal exponent power negative lambda time lambda power x factorial. So we can put P equal P x more than 0 equal 1 minus P x 0. So this because 0, so P x 0 equal 1. We put the equation for this, replace exponent 3 0 factorial 0. So we get the answer 49787 policies. So so for the B, the question is 2 or more policies but less than 5 policies. So we consider P equal 2 more policies x and less than 5. Oh, sorry for this, less than 5, not equal to 5, just less than 5. So we can put the P x2 because 2 equal to 2 plus P x3 plus P x4. But because did not say the equal to 5, just say less than 5, we don't need the P x5. So only 3 this we add. So we replace to the this equation exponent negative 3 2 factorial plus exponent power negative 3 times 3 exponent factorial 3 plus exponent negative 3 4 factorial. So we get 0.0224 plus 0.224 plus 0.138. The answer is 0.616 probability. So this is the answer. Okay, we continue to another question for another example for another subtopic. So this is our subtopic for normal distribution. This is a question for standard normal distribution. If mean of a given date for a random value is 81.1 and standard deviation is 44.7, find the probability of getting a value more than 83. So from this question we know that our mean is 81.1, standard deviation is 40.7. So the question want more than 83. So we find the z with formula x minus mean divide standard deviation. So 83 minus 81.1 divide 4.7, we get 0.40. So from this we refer to the z table. So we can show 0.4. So we think 0.4 and 0.0. So we get the answer is 0.1554. So we can see the graph 0.4 this, so more than this. So we use the equation P equal 0.5 plus this 0.1554. So this equal 0.6554. So we using the formula 1 equals 0.6554. The answer is 0.3446. So we get this answer. Okay, we move to another question. Example, this is for the subtopic normal distribution approximation to the binomial distribution. So the question is, suppose that a sample of n 1600 tires of the same type are obtained at random from an ongoing production process in which 80% of all such tires produced are defective. What is the probability that in such a sample 150 or fewer tires will be defective? So we take out the data from the question. So we get n equal to 1600. P we get from this the 80%. P equal to 80%, so 0.8. So the question one, sample 150 or fewer, so up to the 150, so we can conclude P equal X more than less than 150. Okay, so we find the mean equal to NP, so 0.8 times 160, we get 1 to 8. So we get 1 to 8. So for standard deviation, square root NPQ equal to 1 to 8 times Q we can get from Q 1 minus P, so we get 0.2. So this square root Q times 0.2, 128 times 0.2 square root, we get 10.852. So because they need a fewer tires, so we can we need 150 and fewer, so we don't need 150, so we can conclude to the Px more than 150.5, because we need the question need the 150, so we take the upper than 150, so we take the 150.5, so we can find the Z. P Z equal 150.5 minus 1.8 divide to standard deviation 10.852, so we will get 2.07. From this we will refer at the table. So from the table we take 2.0 plus 0.07, find 0.4808. So we graph okay, so this is the graph. So this for the 2.07. So this is 0.5, so we PZ 2.7 unit 0.5 plus this. From the table we get 0.4808, we get 0.9800. So we get this because this is for the 150. So 150. So we need from this. So we don't need for upper, we need lower than 150. So we get this. This is the answer.